Okay, let's start off the session. Samir and Sunny and Saurabh, sorry, Joshna, and today we'd like to talk about hierarchical clustering, which is one of the machine learning from the supervised unsupervised machine learning algorithm. Okay, I think yesterday we seen that k-means clustering, right? Okay, so today's
Yes.
concept is it's a hierarchical clustering. It's a second type of a clustering algorithm. Okay, nothing too much about this thing. Actually, it's a very simple thing. It's a very similar to the k-means clustering, but in case of k-means clustering, we have to we have to mention the number of clusters, right? But in case of hierarchical clustering, you don't need to mention the number of clusters actually. Okay, so it can be created or it can be figure out itself. Okay, number of how many groups or how many clusters it is having it. Okay, so the hierarchical clustering is also called as the hierarchical clustering analysis or else HCA. Okay. So here the method is analysis, a cluster analysis, which seeks to build the hierarchy of clusters. Okay. The strategies for the hierarchical clustering generally fall into the two ways actually. One is the agglomerative and second one is the divisive actually. Okay. So agglomerative in the sense which is the bottom to top approach, and divisive approach is nothing but a top to down approach actually. Okay, like the difference of these two things here, in case of agglomerative concept, each and every observation initially it's itself it's a one cluster. Okay, that means the data set which is having the 50 50 observations, that means initially it feels that it's a 50 clusters. Okay, after that one the next level, the next hierarchy. Okay, if we have the similar properties from that all clusters, it can be creating the second group, a second hierarchy. Okay, and from that second level hierarchy, okay, if we have similar properties, then it will be creating the one more group or one more cluster. So that's a way agglomerative concept will work actually. Okay, and coming to the divisive approach, from this particular situation, all observations are one cluster. It initially it feels that all observations are one clusters. After that one, it was split into different groups or different hierarchies or else clusters. Okay, depends upon the similar properties. Okay, clear. So so here it is a combining the clusters or grouping the similar clusters. Here it is the splitting. That is the two difference between the agglomerative and divisive approach. Any questions?
No.
So in general, the merge and splits are determined in a greedy manner. The results of hierarchy cluster are usually represented by the dendrogram. So this is the term you need to remember actually. Okay, how we can able to representing the or presenting the your hierarchical clustering with help of the dendrogram only. Okay, the dendrogram, it will show you the how many number of clusters or how many number of groups it can be created. Okay, the first thing is that it's a agglomerative clustering. Initially, each data point, it should be considering the individual cluster. At each iteration, the similar clusters are merged with other clusters until the 1 by k clusters are formed. Okay, and the main advantage is that we don't need to specify the number of clusters before we build it. Okay, this outcomes with the price and performance is it's a this many times in scikit-learn implementation we can specify the number of clusters so assist the algorithm performance. Okay, so here the algorithm is we have to compute the matrix and each data point to be considering the cluster, and we need to repeat the merging the closest clusters until unless it will form the 1 by k clusters actually. Okay, clear. So this is the small example. A, B, C, D, E, F are the observations. So maybe BC having the same properties so that it was merging B and C. It could be one cluster, and D and E having the one group. Okay, or maybe same features or same properties so that it could be one group. And coming to that, this combination of the DE and F having the similar properties, then it could be a one group. So, and coming to this one, BC and DEF having the same properties, then it could be a one group. So this is the way it will go for the, okay, it will be merging the similar property clusters. Clear? But when it comes to the divisive, divisive is the reverse of this one. Okay, all are one group, and it was dividing into or splitting into different clusters. That is the divisive approach. Clear?
Here.
So you just see this graph. This graph. This is the thing we are calling it's a dendrogram. Okay, the dendrogram, the hierarchical clustering is working based upon the dendrogram only. This dendrogram is a tree-like diagram, and that records the sequence of merging or splitting your clusters. Okay. Yep. Let me take some example. So we have to import the libraries over here, and we are importing all data, and this is my data set which we have it, and I was importing, and this is the balance and balance frequency and purchase and one off purchase, installment purchase, and cash adverse, and purchase frequency, and like we have a data set of the credit. Okay, credit card data. This is my credit card data. Okay, so based upon the credit card usage, we have to make the we have to analyze the group of people or clustering concepts. Okay, like initially I want to make the data could be in a similar same scale. That's the reason I can go ahead with the standard scalar. Okay, feature scaling. So with help of the standard scalar, we are making entire data, it could be in the same level or normalizing your data. Okay, and your data could be converting. Okay, you're converting the numpy array to pandas format. Once it is pandas format, and with help of the PCA, we can reducing the dimensions of your data set. Okay, so this is my entire data set. Okay, so now what I can do, I would like to go for creating the dendrogram. So for that one, we have a dendrogram function is there, and we are using the linkage, and we are taking the x principal your data, and method we are using the award method. And so when you display this one, which is creating the some groups right here, um, this level 1, level 2, level 3, level 4, and level 5. There is a 5 levels we have it. Okay, so this is the way, or 5 to 6 levels we have it. This is the way you can able to identify the how many number of clusters we have it. See, this level. Okay, this is one level, and 2 and 3, 4, okay, 6. Like we have a different groups, right? 1, 2, 3, 4, 5, 6, or else 2 or 3 are groups. You can mention as you like it. So this is the way you can implementing the dendrogram. So with help of the dendrogram, so we can finding the optimal number of clusters. Okay, so here we are taking the range, it could be 2 to 8, and you're appending the your score and your agglomerative clustering concept, and you're identifying the score of each and every cluster. So I'm plotting the score, each and every score of the corresponding cluster. Okay, if you have the two clusters, okay, the score it could be it's a more than the 0.5. And if you have the three clusters, even the score could be high only. Even if you have the four clusters, the accuracy, the score was reduced. And if you have the five clusters, the score is reduced, little reduced, right? That means if your number of clusters are increases, okay, number of clusters are increases, your accuracy was reducing. Okay, so building and utilizing the cluster model for k equal to 3. So here the k equal to 3, which is simply identifying that we have three clusters are there. Okay, so that means here accuracy it is not it is reducing when you're increasing the number of clusters after the 3. So I feel it's a number of clusters are 3. So now once if you're finding the number of clusters and you're giving that how many number of clusters for the agglomerative cluster concepts, then it will building the okay 3 clusters group actually. Okay, so you just plot the entire thing, then it was giving the 3 groups. This is one group and this is one group and this blue could be one group. This is the way, this is the way you can able to go for the analyze the clusters with help of the k-means or else hierarchical clustering. Clear? So here interview question is how you can figure out the number of clusters. Okay, that particular situation we can say when I'm using the hierarchical clustering, I can go ahead with the dendrogram. Based upon the dendrogram, and I can finalizing the number of optimal number of clusters. If you're using the k-means clustering with help of the elbow method, we are identifying the number of clusters. Clear? Any question?
Clear.
So this is about clustering concepts, guys, and you can Google it like Kaggle hierarchical clustering. You will be getting a lot of formats, and go and open any one of it and try to be implement your own okay code. So that's for today's session. Hopefully you understood machine learning concepts from the cluster. You understood the clustering concepts and classification concepts and regression concepts, right? Okay, and I would like to explain about mm, by tomorrow session I can explain you deep learning. Okay, I mean artificial intelligence concepts. That thing I know how the deep learning is working and what is forward propagation, backward propagation, and forward propagation, and what are the steps it was involving, and how that backward propagation is working. Okay, that kind of things I can explain you from the tomorrow session onwards. Okay, it could be the deep learning, and it might help you in case of interview or else work level as well. Okay, so as of now we feel it machine learning concepts are done, and it's never ending process. It's a keep on practice different projects and different algorithms, and then you will be getting the some knowledge. Hopefully you got it. And this week I would like to finish it to deep learning classes as well. So our entire machine learning module I would like to finish it by this week itself. Okay. Yep. Bye guys. Thank you.
Excuse me.
Yep.
Can you post the videos from the tablet today? I wasn't able to attend. And
Sorry.
can you post the video from Tableau today's Tableau session? Can
Sure.
you?
Sure.
Okay.
Sure. Sure.
Okay. Thank you.